The very last topic of our chapter number 1 was scalars and vectors. Over there, we studied the resolution of vector into perpendicular components, and those components are very useful in this chapter. This is the primary reason that after the chapter number 1, we are starting off with this one, which is the moment of force or turning effect of force. So this is not a new concept. First of all, this is something that you have already studied in O levels or your IGCSE. All right, so there would be a build up on those concepts. There would be some new variations, different types of questions other than those traditional ones, and in this one we'll be dealing with the components of vectors. This would be the main addition. So let us have a recap. On the cover page I have the picture of Archimedes, one of the pioneers of these concepts. He was a mathematician, he was a physicist, and these are the learning objectives. You can have a look at that. The first part of the chapter is turning effect of forces, and the second half of the chapter is equilibrium of forces. So equilibrium of forces mainly deals with the principle of moment. Data sheet that would be given to you in the exam. Formula sheet would also be given as it is. It is the effect of a force that causes an object to rotate or to turn or to twist. This is the moment of force. Okay, so this is not the exact definition that you're going to write in the exam. This is just for the conceptual understanding. So let's start noting it down. Alright, so this is for the understanding. We say how effectively a force can cause the object to rotate or to turn or to twist. उस चीज़ को हम कहते हैं moment of force. Now, for the exact definition, they ask you a question for 1 mark, sometime for 2 marks as well, कि define moment of force. तो उसमें आपने ये वाली definition नहीं लिख के आनी. What you write is the same one you would have studied in O levels. So it is a product of two things. What you need to do is keep in your mind the moment of force is a mathematical definition, and it is the product of two things, force and the perpendicular distance. And obviously distance has to be between at least 2 points. What are those points? The first point is the point for the line of action of force and the axis of rotation. If you find the perpendicular distance between those two and you multiply by the force, then you get the moment of force. So this is how you define it. If they ask you for the definition, this is what you write. Now the next thing is a formula, the most important one. So the formula of this thing is, it is written as tau. This symbol is used to represent moment or turning effect of force or torque. All of these three terms can be used, and that moment of force or torque equals to the product of force and perpendicular distance from the pivot. So just that you keep it in mind that it is a perpendicular distance, I'm going to insert the symbol of perpendicular. ठीक है, इस तरह से आपको याद रहेगा कि ये जो डिस्टेंस है ये perpendicular distance है. Okay, so generally the examiner would try to confuse you with the distances. So in the examples I'll show you how do we figure out the perpendicular distance. The next thing is the unit. So what you can do is you can derive the unit. It is a product of force and distance. The unit of force is Newton, the unit of distance is meters. So the SI unit of moment of force would be Newton meter. And if they ask you to break it down into base units, you can break it down into base units as well. And that would be the same base units as of joules. The second thing is moment of force or the turning effect of force, it is a vector quantity. Okay. Now what we have is the factors that would affect the magnitude of turning effect of force or moment of force or torque. So there are three factors that would affect the magnitude of turning effect of force. Number one, magnitude of force. Alright, so you keep everything else constant and you increase the magnitude of force, then the moment of force would increase. Alright, so just like you have a spanner or anything, now you increase the force from 10 to 20 newtons. Everything else is constant. Then the overall moment of force would increase proportionately. The next thing is, the other thing that affects the moment of force is perpendicular distance from pivot. And the third thing is, students, they generally memorize the first two and they forget the third one. It is the angle at which the force is applied. The first thing what you can do is increase the force. Let's say you're applying a force of 10 Newton. Now you apply a force of 20 Newton. In that case, the moment of force would increase. Okay? The second thing would be, try to apply the force as far away from the pivot as possible. So instead of applying the force over here, try to apply the force at the end of the spanner. Because if you apply the force at the end, so this is your line of action of force and this is your perpendicular distance. So if you increase the perpendicular distance, the moment of force would also increase. So done with the first two factors. Now the third one. Let's say you're applying the force at the end and the force that you're applying is 10 newtons. The first force that you apply is at an angle. At a certain angle, it might be 30, 40, 50 degrees. The other person who is applying the force, he applies a force perpendicular to the surface at 90 degrees. The amount of force is same, magnitude of force is same. But the thing is, for the person who was applying the force perpendicularly would be able to produce more moment of force. और वो जो उसका काम होगा, it would be more efficient. He would be in a better position to open the nut. So three factors: increase the force, increase the perpendicular distance from the pivot, and apply the force perpendicular to the pivot. Let's move on to the next thing. How do we find the angle for finding the moment of force? How do we select the angle? So in this situation, this is your object, कोई भी आपका object है, and P is the point where the force is being applied. ठीक है, point P पे force आपकी apply हो रही है. This point at the back is your pivot. ये जिसको मैं O से represent कर रहा हूँ, this is your pivot. So they ask you a question, label the angle which would be producing the moment of force. So what you need to do is join the pivot and the point of application of force with a straight line. So you take a straight line, join these two. You can do it with the dotted line if you want. Next step, you mark the angle from this line towards the line of force anti-clockwise. And that would be your angle for the moment of force. You can call it theta. So this theta is your angle that you'll be using for the calculations for finding the moment of force. Okay, but in most of the cases, like in 95-96% of the time the angle is given directly or indirectly. इस तरह की situation बहुत ही काम आती है. Alright, so these are the steps that you need to execute to find the angle which would be responsible for the moment of force. So just the same one जो मैंने explain किया, it's just the same thing. So let's move on to the next thing. This is a situation when the force and the distance, they are not perpendicular to each other, and this is a new concept that we have here in A levels. All right, in all of the questions in IGCSE and O level physics, we used to have a situation where force and the distance were always perpendicular to each other, or they were parallel. In the case they were parallel, we used to say there would be no moment of force. Now if you check out the diagram, what you see is we have a force. Let's say a force is being applied by a person on the spanner. This is the distance from the pivot. Okay, once again, this is your pivot, and the distance between the line of action of force and the pivot is given as distance d. But if you take a look at the diagram, you'll find out that this is your distance vector and this is your force vector, and these two are not perpendicular to each other. So what do we do is we resolve the distance or force into perpendicular components, and from those two components we'll choose the component that is perpendicular to the other thing. Now what do I mean by that? Let me explain over here. This was your force. Okay, you don't need to draw this one, we have to write some description here, this is just for the understanding. And this is your distance. Now the thing is, the distance and the let's direct it over this side. The distance and the force, they are not perpendicular to one another, so I'm going to resolve the distance into perpendicular components. I hope you remember how to resolve the vectors into perpendicular components. And this angle is given as theta, this angle is given as theta. If this angle is theta, this is your vector, this is your displacement vector. So what you need to do is you draw a vector, you resolve the vector in such a way that one of them you can make it along the y-axis in this situation and the other one along the x-axis. The component of the vector that is with the angle directly touching the angle, this component of the vector would be the vector times cos theta. Since the vector is d, so d times cos theta, because this vector, the lower one, let's make it with the green line, this vector equals to d cos theta, and the other component which is not directly touching the angle, that would be d sine theta. You see this one, the red one is not touching the angle directly, so this one would be d sine theta. Now the thing is, you have to choose the vector, the component of the distance that is perpendicular to force. So we have to choose either d sine theta or d cos theta. Now what do you think, out of these two components, which one is perpendicular to force? Not parallel, parallel or anti-parallel is just the same thing, but which vector is perpendicular to force? Which component? What do you think? D cos theta, this is along x-axis, F is along y-axis, so you get a 90-degree angle over here. So d cos theta is the component that is perpendicular to force. So what you see is we resolve the distance into two perpendicular components. One of them was d cos theta, and d cos theta was perpendicular to f. You can check it out from here. The angle between this one component and the force is 90 degrees. So this is a component of distance that would be responsible for moment of force. Then the question is, why do we resolve the distance, or in this case you can call it displacement because we want to call it a vector, but if I say displacement or distance, in this situation would be the same thing. So why do we resolve the distance or displacement into components? Why not resolve the force into components? Why not resolve the force F into components and then find out which component of force is perpendicular to distance? And the answer is, you can do it either way. You can resolve the force into components and then find out which component of force is perpendicular to D. You'll be getting the same answer. Why do we prefer to resolve D into components in this specific situation? Because the thing is, force is already vertical. So anything which is horizontal or vertical, you don't really want to resolve it. Rather, it would be easy for you if you resolve something which is at some other angle. You can resolve that one into components. So one of the component would be vertically upward or downward, and the other one would be sideways. But if you resolve the force into components, you'll be getting the same answer anyway. Okay, so let us try out a question. Here we have this one, and this is a situation where this is the first case where all of the forces are perpendicular to distance. But the thing is, it is slightly more advanced to the question that we used to have in O levels. In O levels, we used to have probably not more than two forces, and sometimes we used to have a question with the weight as well. So maximum would be three forces. Here we might be having four or even more forces. So let's check out this one. This question says a rigid L-shaped lever arm is pivoted at point P. So this is your pivot. Okay, point P. Three forces act on the lever arm as shown in the diagram. What is the magnitude of the resultant moment of these forces at the forces about point P? So for the direction of moment, it is either clockwise or counterclockwise or anti-clockwise. And if clockwise moment equals anti-clockwise moment, there would be no resultant moment. If one moment on one of the side, let's say clockwise, is greater than the other one or less than the other one, there would be resultant moment of force. So let us find out how many of these three forces, 1, 2, 3, how many of these forces or which one of these forces produce clockwise moment and which one of these forces produce anti-clockwise moment. So जो clockwise produce करेंगे उनके साथ मैं C लिख दूंगा और जो anti-clockwise produce करेंगे उनके साथ हम A लिख देंगे. So in order to understand that is कि आप consider the pivot. So you're holding an object at this point, and then from the other side, if you apply a force upward, will this object move clockwise or anti-clockwise? देखो इस पॉइंट से इसे होल्ड किया हुआ है ऑब्जेक्ट को एंड यू ट्राई टू पुश इट अप फ्रॉम दिस पॉइंट, तो ये क्लॉकवाइज मूव होगा या एंटी क्लॉकवाइज? व्हाट डू यू थिंक? इट विल मूव इन दिस डायरेक्शन, राइट, व्हिच इज एंटी क्लॉकवाइज. It is against the direction of the motion of hands of clock. So this would be anti-clockwise. इसके साथ A लिख देते हैं. Take a look at the lower one. So if you try to push it downwards at this point, so the direction of motion of this object would be something like this. Okay, this direction, which is consistent with the direction of motion of the hands of the clock. So ये कौन सा moment होगा? Clockwise. तो इसके साथ C लिख देते हैं. And let's take a look at the last one. So for this one, if you try to apply a force on the right side, ठीक है, इधर से कर लो या बेशक इधर से कर लो. For sake of convenience, just try to assume that you're applying the same force over here. So because the line of action of force is same, ठीक है. So if you apply a force on this side, this object would move in this way, which is anti-clockwise. इसके साथ भी A लिख देंगे. So we add all the moments clockwise on one side and we add all the anti-clockwise moments on the other side. So let us find the moment produced by this force. ये किसके इक्वल होगा आपका? ये इक्वल होगा force times the perpendicular distance of this force from the pivot. Force times the perpendicular distance between the line of action of this force from the pivot. So this is your line of action of force and this is your pivot. And what is the distance between these two? So देखो टोटल आपके पास था 4 में से ये टोटल यहाँ से यहाँ तक आपके पास 4 meters है. Out of that 4 meters, 2 meters are on the right side. जो remaining 2 meters होंगे, that would be on the left side. So the distance of this force from the pivot is 2 meters. ठीक है, तो ये distance आपका कितना है? 2 meters. So what would be the moment? Since moment is a product of force and the perpendicular distance, तो ये moment हो जाएगा 5 times 2. So this is 5 times 2. ये क्या आपका? This is a moment of force due to the force 5 Newton. Let's take a look at the other force. The other force is 15 newtons. Now what is the distance of this force from the pivot? Perpendicular distance. So देखो, this is your line of action of force. This is your line of pivot. What is the distance between these two? आपको directly given है 3 meters. So ये आपके पास कितना आ गया? 3 meters. So the moment of this force would be 15 times 3. और इसको मैं equals to की right side पे लिख रहा हूँ because that is counterclockwise. That is clockwise. So clockwise सारे एक side पे ऐड कर रहे हैं हम और anti clockwise आपके सारे एक side पे ऐड कर रहे हैं. Then there's a third force which would also produce anti-clockwise. तो इसको भी left side पे add कर लेंगे. And how much moment of force would be there because of this force? देखो, once again, this is your line of force and this is your line of pivot for this situation. What is the distance between these two? 2 meters. So ये भी आपका moment इसका कितना हो जाएगा? 10 times 2. और इसको हम करेंगे एंटी क्लॉकवाइज साइड पे ही ऐड. सो ज़रूरी नहीं है कि एंटी क्लॉकवाइज आपकी लेफ़्ट साइड ही हो. यू कैन राइट इट ऑन आइदर साइड, लेकिन एंटी क्लॉकवाइज वाले आपस में ही ऐड करने हैं. प्लस 10 F इंटू डी, इसका डिस्टेंस आपका बनता है 2 meters. नाउ लेट अस ऐड दीज टू. सो यू गेट 10 plus 10 times 2 would be 20. So you get overall 30 here. Okay, and then 15 times 3 you get 45. Then what you can do is you can subtract these two. 45 minus 30, you get a resultant moment of 15. So you see there is a resultant moment of 15 Newton meter, or a moment of 15 Newton meter is extra anti-clockwise. Now if you want to balance the system, you have to produce some way, you have to produce a moment of 15 Newton meter anti-clockwise. So on both sides you have 45. Like in this situation it can't be balanced because it has a resultant moment which is 15 Newton meter. Now this one question I explained with the topic of couple, so we'll sort it out over there. Let's take a look at this one, and this would be the last page for today. So the angle is given as 50, और यहाँ पे distance मैं आपको दे देता हूँ. Distance उन्होंने आपको दिया था question में 6 meters. The question is simple. Find the moment of force produced by the force of 200 Newton around the pivot. Where is the pivot? ये आपका pivot है O. And the total distance is 6 meters. So you see, this is your distance. Horizontal line is the distance. But then the question is force perpendicular to distance? नहीं, distance और force perpendicular नहीं है. Rather, they are making an angle of 50 degrees. So what do? We need to resolve the force or the distance into components. अब इस situation में किसे resolve करें, distance को या components को? Answer is your choice. I'll prefer कि force को resolve कर लेते हैं because force is kind of tilted, distance is horizontal. Distance आपको straight line से represent हुआ है, horizontal line से. So force के दो components draw कर लेते हैं. This is why we study the topic resolution of vectors in chapter number 1. So we should be able to resolve the force into two perpendicular components. So देखो, force is आपकी जो direction of force है ये आ रही है आपकी top left corner में, top left corner. So one of the component would be top, facing top, and the other component would be towards left. क्योंकि the force was in the top left corner, so the components would be, one component would be upward and the other one would be towards the left side. Okay, this is just to explain it. ठीक है, easy way explain करने का है सिर्फ. Now, out of these two components, which component would be this one? F cos theta या F sin theta? ये जो component है मुझे बताओ ये कौन सा होगा? F cos theta होगा या F sin theta होगा? This one would be F sin theta. Reason? Because this component is not touching the angle directly. जो angle 50 degrees है वो आपका इस component के साथ नहीं बन रहा. So the component which is touching the angle, जिसके साथ आपका angle बन रहा हो, that would be vector times cos theta. So the lower one would be F cos theta and the upper one would be F sin theta. And then you can find the value of it because आपको पता है F कितना है 200. So 200 times sin 50. ये कर लो कितना आता है. और आपका लोअर वाला हो जाएगा 200 times cos 50. ये भी आप कर लो. Then you find out कि out of these two vectors, now the most important question, out of these two components of force, F sin theta and F cos theta, which one is perpendicular to distance? F cos theta या F sin theta? Which component is perpendicular to distance? आपके distance की line ये है horizontal, एक component है force का इस side पे, दूसरा है आपका इस side पे. इन दोनों में से कौन सा आपका component perpendicular है distance के? F sin theta या F cos theta? See, this situation, the component F sin theta, देखो F sin theta is making an angle of 90 degrees with the distance. So F sin theta is perpendicular to the distance. Now when you need to find the moment of force, you rewrite the formula. Force torque equals to, या moment of force equals to force times the perpendicular distance. So force आप 200 ही यूज नहीं करेंगे because 200 was not perpendicular to distance. Okay, so the force which was perpendicular to the distance is 200 sin 50. जो भी इसका आंसर आएगा, या F sin theta. Or should I be writing, if I be more precise, I should be writing it perpendicular force into distance, because we have resolved the force into components, but it would be same anyway. So this component of force was perpendicular. All of it is the value of force times the value of distance is 6 meters. ठीक है, कैलकुलेटर पे जब आपने लिखना है सो मेक श्योर कि साइन 50 के बाद आप ब्रैकेट्स लगा के ब्रैकेट्स क्लोज करके फिर मल्टीप्लाई बाय 6 लिखो. अदरवाइज वो कैलकुलेटर क्या करेगा, वो आपको साइन 50 टाइम्स 6 जो 300 आएगा वो 300 का साइन ले लेगा. फिर ये नहीं हमने करना. वी हैव टू टेक साइन 50 मल्टीप्लाई बाय 6 multiplied by 200. So the final answer for this one would be 919.25. 919.25. Since all of the data is the lowest data is in 1SF, so अगर आपने 1SF में करना है तो round off कर लो. It would be 900 Newton meters. If the distance were given as 6.0, 2SF में given होता, we could have been writing as 920. Alright, depending on the data. Agar the lowest data is in, the lowest number of significant figures in the data is 1, 900 would be the answer. If the lowest number of significant figures in the raw data is 2, then 920 would be the right answer. So in some of the questions जिसमें उसने पूछा होता है कि give your answer to appropriate number of significant figures, उसमें तो आपको ध्यान रखना पड़ता है, otherwise they'll deduct the marks. और यहाँ पे भी practice तो यही है कि the student should be aware of the number of significant figures and they should practice accordingly.